Problem number 27. I tell you if x is less than 3, I ask you to think about, can you write something that's equal to absolute value x minus 3 without using absolute value bars? And so the thing to remember is our definition for absolute value of x is going to be, this is either equal to x or negative x. It's equal to x if x is greater than or equal to 0. It's equal to negative x if x is less than 0. So if we replace x with x minus 3 here, this is equal to, the absolute value x minus 3 is equal to x minus 3, or negative x minus 3. It's equal to positive x minus 3 if x minus 3 is greater than or equal to 0. It's equal to the negative of x minus 3 if x minus 3 is less than 0. And x minus 3 is less than 0 is exactly equivalent to x being less than 3, as requested here, as you were told. So this part, it's true, but it's irrelevant for the problem. And so our answer here is that the absolute value of x minus 3 is the negative of x minus 3. Okay, so this is what we have here. This is our first part. Now for part B, I ask you to compute the limit as x goes to 2, absolute value of x minus 3 minus 1, and all of this divided by x minus 2. Now before we do that, we can just go ahead and jump right into things here, because as x gets close to 2, those values of x are close to 2 are all going to be less than 3. So we can replace absolute value x minus 3 here with the negative of x minus 3. Minus 1, all of that over x minus 2. Okay, so what do we have now? Negative x plus 3 minus 1 over x minus 2. This is the limit as x goes to 2 of negative x plus 2. We can pull out a negative sign from that. It's negative times x minus 2 over x minus 2. Cancel these out, and it's just the limit as x goes to 2 of negative 1, which of course is negative 1. So what's going on here? It's helpful to remember this kind of stuff here with absolute value, so that we can know here if x is less than 3, we can know how to simplify this, rewrite it without the absolute value bars. Because down here, as x goes to 2, we're thinking about values of x close to 2. Values of x close to 2 are certainly going to be less than 3. So we can make this replacement, and the rest of the problem is relatively straightforward. Okay, question 28. Tell you limit as x goes to 0, f of x equal to 4, and I ask you to evaluate that limit there. So the limit as x goes to 0 of x times f of x divided by sine of 5x. Now to answer this, let's recall our limit as h goes to 0 of sine h over h. This limit here is equal to 1. And by using reciprocals here, I think I did this in a previous video, so I'm going to kind of skim this over a little bit. It's also true that limit as h goes to 0 of h over sine h is equal to 1. So why do we care about this? Well, if we see here we have sine of 5x, and we replace h with 5x, this is going to give us the limit as if 5x goes to 0, well, x is also going to 0. of 5x over sine of 5x is equal to 1. So we know this, we just kind of derive that. We also know, as given in the problem statement, the limit x goes to 0 of f of x is equal to 4. So let's manipulate this limit here so that we have things that look like this going on. Okay, so this limit is going to be, limit as x goes to 0 of 5x over sine of 5x. Now, I made that look like that here. I multiply by 5. What's the cost? I have to divide by 5. And I still have f of x hanging on over there. And I can furthermore rewrite this, because the limit of this exists in this finite, limit of this exists in this finite, limit of this exists in this finite. I can rewrite this as the limit as x goes to 0 of 5x over sine of 5x. That entire limit times the limit as x goes to 0 of 1/5. That entire limit times the limit as x goes to 0 of f of x. And we know all three of these limits here. This first limit is 1. The second limit is 1/5. And this third limit, as given in the problem, is 4. So our final answer here is 4/5. So it's helpful to know these rules here along with product laws for limits.